Hello and welcome to Miss Riley's Maths videos. This is a video going through arithmetic sequences, which in junior cert you knew as linear sequences. It's the same idea, but in leaving cert we generally call them arithmetic sequences. And in this first video of about 4, I'm going to look at what is an arithmetic sequence, what is meant by A and D, what is Tn, and how do I use Tn to find terms in the sequence. So the first thing, let's take a sequence, 5, 8, 11, 14, 17. So here's a sequence. A sequence is a set of numbers that follow one after the other, where we can see something that happens to each term gets it to the next term. So looking at this sequence, hopefully you can see that actually to get from 5 to 8 we add 3, and that's the same as to get from 8 to 11, and that's the same to get from 11 to 14 and 14 to 17. So this is an arithmetic sequence because it's got what's called a common difference. So a common difference means that when I subtract 8 minus 5, I get 3, and when I subtract 11 minus 8, I get 3, and when I subtract 14 minus 11, I get 3. It's a common difference. I'm going up by the same amount each time. I'm adding on 3 each time, or you can say the difference between any two consecutive terms. Common difference between any two terms, any two consecutive terms is the same. Okay, so that's what an arithmetic sequence is. The difference between any two consecutive terms is the same. Okay, that common difference is called D. So in this case, D is equal to 3. So that answers our second part of our second question, what's meant by D. D is the common difference. A is the first term, or the starting term. Starting term. So in this sequence, you can see that A is 5. Okay, so A is 5, D is 3. Now, another name for A, for the starting term for the first term, is T1. So that's T1, that's A. And if this is T1, you can probably guess that that's T2. Now, do you notice the way it's T with a little what's called a subscript? So it's not powered, it's not T to the power of 1 or T to the power of 2. It's not that. It's a little subscript, it's a little label rather than a power. Okay, so T3, T4, T5. So in other words, T1 is the first term, which would be 5. T2 is the second term, which would be 8. T3 is the third term, which is 11, etc., etc. Now, there is a T with a little n, which means the general term of a sequence. Okay, the general term of a sequence. So that little n again is the label. Another name for that is the nth term, and I sometimes call that the any term. Okay, so Tn can also be known as the nth term. It can be known as the general term. I sometimes call it the any term. Basically, when we see Tn, usually what's happening is we're being given the rule to find any term in a sequence. So if we're given the Tn, we know that it'll give us a rule, it'll give us a way of finding any term in a sequence. It's kind of a formula. It's like a formula to find any term in a sequence. So for instance, if I know for this, I can tell you that the Tn, the rule for finding any number in this sequence, or any term in this sequence, is 3n plus 2. That's the rule. What does that mean? That means that, for instance, if I wanted to find, I've got 5 terms there, if I wanted to find T6, do you notice how n and 6 is gone where the n is? So T6 would be 3 times 6. See, there's an n again. This 6 is where the n was, so this 6 is going where the n was, plus 2. Would be 18 plus 2. 3 times 6 plus 2, because 3n means 3 times n. 18 plus 2 is 20, so T6 is 20. if you look at this, that makes sense, because to add 3 onto 17 would give me 20. That makes sense. Okay? If I wanted to find T100, so what's the 100th term in this sequence? If I kept on adding 3, adding 3, adding 3, adding 3 all along, what would happen for the 100th term, the 100th number in this long list of numbers? What would that be? So that would be the 100th term. This is the 6th term, or the 6th term. The 100th term, well, if you notice, n is now 100. So it's going to be 3 multiplied by 100 plus 2. So the 100th term in this sequence is 300 plus 2, which is 302. So if I listed all 100 terms of this sequence, the last number I would write down, the 100th term, would be 302. That's what the general term is. So that's what the general term is, and that's how I use it to find terms in the sequence. So what you might be told is something like this. Tn of an arithmetic sequence is, let's say, 4n minus 3. Find the first 4 terms of the sequence. Okay, is the general term of an arithmetic sequence. So the first 4 terms are going to be T1, T2, T3, T4. Tn is 4n minus 3. So T1, that 1 is where the n is equal to 4 by 1 minus 3. So 4 minus 3, which is 1. So T1 is 1. There we are, T1. T2 is equal to 4 by 2 minus 3, which is 8 minus 3, which is 5. So T2 is 5. Now, if I wanted to, I could say, well, this is an arithmetic sequence. The difference is 4. I can add on 4 and get the next term. But just to practice, I'm going to do T3. T3 is 4n minus 3. n is now 3. 4 times 3 minus 3, 12 minus 3, which equals 9. So T3 is 9. Does that make sense? Yes, it does, because if I add 4 to 1, I get 5. If I add 4 to 5, I get 9. And let's find T4. We expect it to be 9 plus 4, which is 13, but let's just see T4. n is now 4. 4 times 4 minus 3, 16 minus 3, which equals 13. So T4 is 13. And so on. Okay? So T4 is 13. T3 is 9, T2 is 5, and T1 is 1. Now to find any other term, say I had to find T50, well then again I use my Tn is equal to 4n minus 3, T50, n is now 50, is equal to 4 by 50 minus 3, 200 minus 3 is equal to 197. Okay, now slightly different question, just to finish this off. They might say, which term of the sequence has a value of 197? In other words, how far along the sequence do I have to go before I get 1197? Another way of saying that is Tn is equal to 1197. Find the value of n. Okay, those questions are both asking the same thing. So Tn is equal to 1197, but Tn is also equal to 4n minus 3. Those are both Tn for this particular sequence. If they both equal Tn, then these two equal each other. So I can say 4n minus 3 is equal to 1197. If I add 3 to both sides, I get 4n is equal to 1200. So n, dividing both sides by 4, I get n is equal to 300. So what I found is that the 300th term of the sequence, the sequence 1, 5, 9, 13, the 300th term of that sequence, T300, is equal to 1197. Okay, watch the second video if you need to. Thank you.